Hey there guys, you're watching Code Lab. I hope you're all doing really well. I'm really excited to show you guys this video because I feel this topic is often overlooked and neglected, and that topic is responsive images. And now I don't just mean this in the usual flexible way, which we will be looking at in this video, but responsive images actually go much deeper than this. So aspects such as resolution, picture ratio and web performance often never get mentioned and are actually crucial in taking you from that amateur level programmer to that master level programmer, and also providing the best user experience within your projects. So in this video we're going to be diving into those aspects of responsive images and explaining them in detail for you guys to help you guys master responsive images, and make sure you watch until the end for a bonus tutorial on images. So just before we get started guys, if you guys enjoy the content, be sure to hit that like button and subscribe to the channel, and make sure you turn on notifications as I post weekly content so you guys never miss an update. Now we're just going to kick things off with starting at the basics, and that's using relative units to make our images responsive in a flexible way. And you guys can ignore that E equals empty squared, I was just trying to be funny. So let's head into VS Code now and start making our images flexible. Now inside the browser you can see the image that we're going to be using throughout the tutorial, and inside the style sheet to our left you can see I've given this a width of 800 pixels. Now this image currently looks fine at this screen size, but if I grab the browser and I start shrinking this down, you can see we start now getting scroll bars, and the image starts getting cut off, and it's just not responsive at all or flexible, and this is just a massive no for us. Because the objective here is to make this responsive. Now of course the reason this is happening is because if I bring this back, we're using pixels. Now pixels are what you'd call a fixed width, meaning our image, as you can see, is always going to stay at this width that we specified, further meaning that this image now is not responsive at all. So the first thing we could do instead of using pixels is use relative units. So instead of 800 pixels here, I'm just going to say 100%. So what's happening now is the image now is spanned across 100% of the browser, and it's always going to stay at this width. So if I start shrinking this down, you can see now the image shrinks down along with the browser, and it's much more responsive, which is our primary objective here. So this is great, and now we have a responsive image, but this really is the basic level of responsive design, which everyone should really know. So now we're going to take it up a notch slightly, and another issue we might run into with images are their tendency to sometimes lose their aspect ratio in regards to screen sizes. So what we can do to address this issue is use the property of object fit to help us preserve the aspect ratio. So let's dive into VS Code and look at our example again. So in this example again we're using the picture of the elephant, but what I've done is just wrap the image in a div with a class of container, which you can see there. And the reason I've done this is just so I can center the content. Now the image still has this width of 100%, so 100% of the container now, and meaning that it's still responsive because we're using relative units. Now because we haven't specified a height to this image, the width of 100% also applies to the height of the image, so you can clearly see this when we shrink it down. The height also shrinks, and if we get larger the height also increases. Now in some cases you may not want this, you may want the height to be fixed, so let's just give this a fixed height, 500 pixels. So the image now will be responsive on the width, but it will keep the same height. So you can see here now if I make it bigger it stays the same height, if I make it smaller the height isn't shrinking as it did before with just the height being 100%. Now the trouble with doing this is that even though the height stays the same, the problem we run into is that once we get to a certain point, when we start shrinking it down, you can see the image starts losing its aspect ratio and just starts looking squished. And then if we get to larger screen size, you see the image starts getting stretched, and in some ways it's making it less responsive. Now this can be fixed with the object fit property. Now what the object fit property allows us to do is control how the image will behave within its own parameters. Now by default the value of the object fit is set to fill, meaning that the entire image will completely fill the box, and if the image aspect ratio doesn't match the aspect ratio of its box, then the image will be stretched to fit or squished to fit, and that's why you see it now when we change the dimensions of the screen. It squishes when we get smaller and stretches when we get larger. Now the good thing here is that the object fit property has other values which can be used to crop or contain the image itself. So let's go underneath here and just grab the object fit property. Now in most cases you'll likely use the value of cover, which crops the image so it preserves its aspect ratio. So I'm just going to enter the value of cover here. And what happens now if I start shrinking the screen size, you see the object fit property will start cropping the image to preserve its aspect ratio, and it's no longer getting squished. And the same rules apply if we make the screen larger. So what we've done here is maintain the responsive image while keeping its perfect aspect ratio despite having a fixed width. So that's how we can combine the relative units and the object fit property to create nice responsive flexible images. So currently right now in this tutorial we've created flexible images which respond to the width of the browser using relative units, and we've also made the images more flexible even around fixed units to preserve their aspect ratio using the object fit property. But as I mentioned in the intro, responsive images actually go much deeper than this and go to a whole nother level. Now the two examples I demonstrated work around responsive design, but to really take things to that next level, we're not only concerned with responsive design, but we're also concerned with web performance, because responsive images are actually essential for web performance, and it can really separate an amateur website to a more professional one. Now the philosophy we can work around here is that the primary objective is to serve the right image to the right screen size device using different techniques in HTML. Now because many people around the world have different data plans or internet broadband, wasting unnecessary data on these images which are just too large for their screen sizes is just something we want to avoid. So if we look at this example, you can see here we have an image with a 2 MB data plan, which is fine for large screen sizes, but trying to download it for smaller screen sizes like a tablet or a phone is just not okay. And this will massively affect the web performance for that individual and the screen size, depending on their data plan, which might be more slow or more expensive. And as developers, guys, we really have a duty here for our users to give them the best possible experience. So knowing how to make responsive images for web performance as well as design is what we should aim to achieve when dealing with responsive images, so that we serve the best and appropriate image for that given device and screen size. So there are three main ways we can create responsive images for our projects. We've got density switching, resolution switching, and art direction. And what we're going to do now is go over each one of these individually. So the first and probably easiest way to create responsive images is through density switching. Now density switching, which is a special case of resolution switching, has much more of an emphasis on screen pixel density rather than screen sizes. So to get a bit technical, screen pixel density is related to image resolution, which is typically described in PPI, which refers to how many pixels are displayed per inch of an image. Now high resolution screens mean that there's more pixels per inch, resulting in more pixel information and creating a high quality crisp image. Now low resolution screens have fewer pixels, and if those pixels are too large, it usually results in an image being stretched or blurry, and the quality is pretty poor, which you can see here on the image on the right. Now knowing all this information is important, but what's also equally as important is that there are high resolution and low resolution screens out there, and not everyone around the globe has access to high resolution screens. So again, it's our duty as developers to make sure we can accommodate for every screen, whether they're high or low. Now low resolution screens are typically most PCs, and high resolution screens are found in modern smartphones and some computers with retina displays like Macs. So knowing all this, let's dive into VS Code now and see how we can accommodate for different resolutions. Alright guys, so we're inside VS Code, and as you can see in the folder here for the image folder, I've included 3 images. Now there's elephant 600, 950 and 1300, which basically represent the size of the images in pixels, so they don't really have any relevance here except just to help me remember. So the first thing I'm going to do is go underneath this H1, and I'm just going to include the image tag, and then we're first going to use the source attribute. So we're going to grab the first image here of elephant 600, and the reason we're using the source attribute here first is because this is going to act as a fallback, because some browsers don't support the source set attribute, which we'll be speaking about in a moment. So there's our image there, and what I've also done is just given this a width of 500 pixels, so it has a fixed width now. And then what we're going to do now is go underneath the source, and we're going to grab the source set attribute. So we're going to say source set. Now the source set attribute is probably the easiest possible syntax to use when dealing with responsive images, and what this basically does is just give us a set of sources to choose from. So when we first lay out the image tag, we first get this source attribute, which just links to this one source that we refer to, but with the source set we can link to multiple different sources, which is crucial for responsive design. Now what I'm going to do is include the 3 images inside this source set, so I'm just going to paste them in here, and I'm just going to put this in a new line so it's more readable. So just to quickly recap, we have the image tag here which has one source, so this source here is just going to be the fallback. So if the browser doesn't support source set, it will fall back to this image here, which is just currently the smallest image we have in terms of pixel size. Now if the browser does support source set, which it most likely will, we now have these 3 images to choose from. Now in regards to density switching, the source set attribute is followed by X descriptors, and what these X descriptors do is basically just label the images for us to use on displays with different pixel densities. So let's go ahead and add some density descriptors now. So in this first image, we're just going to go after the source set, and I'm just going to put a 1x in here, and what this is basically for is for low resolution screens. So if our user has a low res screen, this image will be inserted. Now we don't actually need to put this 1x in here, it's already implied, but I just do it for reassurance. Now for the second image here, we're going to apply a 2x descriptor. So if the browser knows it's going to be a high pixel density display, it will use this image instead. So this 950 pixel will fit into this 500 pixel image. So it'll give it a nice crisp look on high resolution screens. And then finally for the third image here, we'll give it a 3x. So if there's an even higher resolution screen, it will use this image instead. So this 1300 pixels will fit into the 500 pixel width. Again, giving it a high quality look. And that's pretty much it for density switching, so pretty simple. So if the device accessing the page has a standard low resolution display with one device pixel representing each CSS pixel, the first image here will display. If the device has a high resolution screen of 2 device pixels per CSS pixel, then the second image will display. So squeezing the 950 pixels into the 500 pixel image. And then if the res is even higher, it will use this third image here. So the 1300 pixel image will be loaded inside our 500 pixel width. So it'll give it a nice crisp look. And to show you guys this is working, I'm just going to open up the inspector tools here. And then I'm just going to click on this little icon here. If we go up here to DPR, which is device pixel ratio, and I click on DPR2, so it should show us the second image. And as you can see there, it's giving us the image 2. So this is what this image is here. So you can see how they're linked. And then if we look at number 3, you'll see it'll give us image 3, which is this image here. So as you can see, this is working as it should. Now, using density switching and the X descriptors are a great way to start responsive images, but they're kind of limited when it comes to changes in sizes, meaning that they work well for fixed widths, but our images are constantly changing sizes in the real world. So another way of doing things is, instead of just focusing on density switching, we can use resolution switching, which actually covers both pixel density and layout size. So we have the right image at the right pixel density, and we also address the issue of bandwidth and web performance. Alright guys, so we're going to be using the same example here, but the first thing we're going to do is just change the width of our image here. So it's not a fixed width, it's going to be a relative one. So we're going to say 100%. So it's 100% of the browser there. Now in the HTML, we're still going to be providing multiple copies of the same image here and letting the browser pick the most appropriate one. But instead of labeling them with the 1x, 2x or 3x descriptors, we're going to be labeling them with their resource width, which is the W descriptor. So the way the W descriptor works is that it correlates to the image's intrinsic width in pixels. So 600 pixels equals 600 width. So instead of 1x here, we're going to have 600 width, because this image is 600 pixels wide. And then for the 950, it's 950 pixels wide, so we say 950 W. And then, as you guessed, for the third image, it's 1300 width. Now you may have noticed immediately that my image has changed to the second image, or the 950 pixel image, and that's because the screen size, or the browser here, is above 600 pixels. And because the browser now already knows the intrinsic width of the images before it even has to load it, with the W descriptors, it automatically knows which image to put at which screen size. So let me just show you guys again quickly what that looks like. So if I delete all of these, it'll revert back to this first image here. But if I put in the W descriptors again, you'll see this image is actually a bit too blurry for this screen size. So I'm just going to put them back in and just pay attention to the image here. You'll see it's actually a lot more crisper than the first image here. And then if we get even bigger, you'll see it starts getting a bit too blurry for the second image, and then it will jump to the third image because it's above 950 pixels, and this image is much more appropriate for the screen size. And this is in effect tackling both issues of adjusting to the right screen size and saving a lot on bandwidth, because a smaller screen size, you don't really need to upload such a massive image, thus indirectly it's maximizing web performance, because the 600 pixel image has a much lower file size than the 950 and the 1300 pixel size image. So just to quickly dive a bit deeper here, the importance of the W behind the scenes is so powerful, because without specifying the intrinsic width of the image with the W descriptor, the browser doesn't actually know the width of the image before it loads. So normally when the browser loads an image, it won't know the width unless you tell it to. So it loads it first and then it knows the size. So what we want to do here is let the browser know the width before it has loaded. So instead of loading all 3 of these images at the same time and then displaying the right one afterwards, it already knows the width with the W descriptors, and it will just load the image for the right size and resolution, again maximizing the web performance. Now leaving it like this would probably work fine for you in most cases, but we can actually go a step further here and actually tell the browser which image we want the browser to display at which size using media queries. Now for this example, I've just changed a few things around. So I've added an extra bit of markup here, and I've put the image and the markup inside a div with a class of container. Now in the style sheet, what I've done is just added a media query. So there's a minimum width here of 650 pixels. So once we go above this, the div with the class of container, will come into effect, and the rules in here I've just used display grid, and we've got 2 columns of repeat 1FR, so that's what it currently looks right now. So we're above this threshold of 650 pixels, so these rules take effect. And you likely see this example in websites where there's 2 columns and one column has an image and the other has some text. So what will happen here, if I lower the screen size down, they'll just stack on top of each other, making it responsive, and then if we get bigger, it'll revert back to that 2-column grid. Now the trouble here that you probably don't realize is that the browser always assumes that the width here, which is in effect correct because it is saying here 100% width, it's always assuming that it's 100% width of the browser, which isn't always the case, because when this media query comes into effect, it then becomes a 2-column grid, and the image is actually around 50% of the browser, not 100% of the browser. So what's essentially happening here is that when we get larger than the 650 pixels, the browser will respond by thinking we've triggered our media query here, and because we're using W descriptors here, once we get past the 600 pixels, it will deploy this image instead, so that's why you can see image 2 in here now. And this isn't really maximizing web performance, because the smaller size image of this 600 pixels would work perfectly fine here. So this is when we can bring in the size attribute to specifically tell it when to deploy the image. So to tell the browser when to deploy an image, we insert the sizes attribute after the last source set. So we'll go underneath here and I'll grab the sizes attribute, and then what we need to do in here is insert a media condition. So we're going to say min width 650 pixels, and then we'll close that off. So we're saying when the viewport width is above 650 pixels, the width of the slot of the image will fill when the media condition is true. So above 650 pixels, my image will take up 50 viewport widths. So we'll just put in here 50 VW, and then after this we're just going to put in here 100 VW again, and this is basically just defaulting back to 100%. So under 650 pixels, the image doesn't take up 100% of the browser because it's stacking on top of each other or on top of the text. So as you can see, after we've inserted this media query here and these rules, you can see that the browser has deployed the first image here, which works just as well, and because it's really more appropriate to use this image here, and it results in maximizing web performance. And then as we get bigger, once we get to a certain size, you'll see that the second image is deployed, resulting in a responsive design. Now this is a pretty basic set of media rules, and you guys can come and play around with this and come up with your own breakpoints which are just more suitable for your projects. Now the last perfectly legit goal with responsive images is not just to serve different sizes of the same image, but to serve different images. So for example, we can crop the image differently depending on the size of the screen and the differences in layout, and this style is referred to as the art direction style. So the example on the screen here, on the left we have a desktop screen with the full landscape width of our image, but if this was viewed on a mobile browser, the image would shrink down and making the elephant in the image smaller and harder to see. So in this case, it'd probably be better to show a smaller cropped out version of the image on a mobile, which crops out the majority of the photo and focuses on the main aspect of the photo, which is the elephant. So despite being the same image, technically they are in fact 2 different image sources, so a wider shot and a cropped out shot. So we're inside VS Code, and inside the image folder you can see we have 6 images. So we have the large and the small version. So here's the small, which is the cropped out version of this large version here. And you can also see we have the 2x and 3x for each of these, because we're going to be in fact combining art direction with resolution to gain that maximum web performance and design. So the first thing we need to do in here is go inside the index folder, and I'm just going to grab the image tag because we need to include our image to bring that image in. So the image we're going to put in here is just the large one, so IMG, and we're going to have the elephant large, which will bring it now into the view of the browser. And it's really important that we include this image tag, which I'll demonstrate in a moment why. Now in regards to art direction, we use the picture element here. So with the picture element, we wrap the image tag here inside the picture element. So we put it just before the closing tag, so it's put inside there. Now from here, inside the picture element, we include the source element. So we're going to go and include the source element. And inside the source element, we include the source set attribute. So we'll put in here source set. And it's really important to use source set here because source won't actually work inside the source tag. So inside the source set, first we're going to include the large image. So we're just going to copy and paste this image here. And then what we're going to do is include the 2x and the 3x version. So I'm just going to put them all in new lines. So we've got IMG elephant large, and this has a 2x.jpg, and then we're also just going to put in the IMG elephant large 3x for the highest resolution JPEG. And then we need to create one more source tag for the smaller image. So we just duplicate that, go down one, and then instead of large here, we're going to change these to small. And then from here, what we're going to do is use what we learned in resolution switching and apply our width descriptors. So the browser already knows the width of the image before it loads, so it loads the appropriate one at the right screen size, maximizing web performance. So for the first one, the first large image here, this has a width of 1000 pixels, so we use 1000W. Now you're going to need to know the width of your images if you want to apply this. I already know the width of these images, so that's how I'm writing this out. I'm not just guessing this. So the 2x version, this has a width of 1300 pixels, so 1300W, and then for the 3x, the high resolution, this has a width of 1500. And then for our small images, the first one has a width of 300 pixels, the second one has a width of 400 pixels, and the last one has a width of 500 pixels. Oh, not pixels, W. It's always important to put the W, not the pixels. Now, just doing all this won't really change much at all. As you can see, if I grab the browser, the image won't change to that cropped version. That's because we need to include a media query in here. So just like in the previous examples, we'll go inside the source tag, grab a media attribute, and I'm just going to insert a condition in here. So we're going to say at a minimum width of 500 pixels, we want this media query to take effect. So if we're above 500 pixels here, it will display the larger image here, and then depending on the resolution, it already knows the width of the images, so it'll apply either the 2x, 3x, or the low res version. And then if we're underneath 500 pixels, it will choose out of this source set, and again it knows the width of the image before it even loads it, so it will apply either a low res, a 2x res, or a 3x res. And just to show you guys this is working, if we go underneath 500 pixels, so instead of showing us the large picture of the elephant, where the elephant is going to be really small and in the center, it's now pretty much taken up the whole image space. Now this media rule here is a bit arbitrary and just basic, so you guys will likely have different breakpoints for your projects. And as you can see now, we've combined the art direction with the resolution switching, and we also have a media query here to distinguish when to show the cropped image or when to show the larger image. And the browser now will also know which of these is more appropriate to use, because we've already defined its width using the W descriptors. And the real beauty here is that even though we have 6 images, it's only going to be loading the image for that specific screen size and resolution and that circumstance. So we're actually really maximizing web performance here, as well as design. Now back to this image tag here, in all cases we must provide this right before the ending picture tag, because otherwise no image will appear, and this is basically just a default case that will apply when none of the media conditions will work, and this will be pretty much a fallback for the browsers that don't actually support the picture element. Now what's also important to add here is that these source tags here aren't referencing the picture tag, they're actually referencing this image tag here. And the reason this is important is because if we want to apply CSS here, we apply the CSS to the image tag, we don't apply it to the picture tag. Now you might be wondering why we can't use CSS or JavaScript to do this kind of stuff. Well, as I've mentioned a few times throughout the tutorial, when the browser starts to load a page, it starts to download any images before the main parser starts to load or interpret the page's CSS and JavaScript. Now this kind of mechanism is useful for general purposes like reducing page load times, but really doesn't help us out for responsive images, hence the need to use the elements we've seen throughout the tutorial and the source set attribute. So for example, we couldn't load the image element, then detect the viewport width with JavaScript, and then dynamically change the source image to a smaller one if we wanted to. By then the original image would have already been loaded, and you would also load the small image too, which is even worse for responsive images. Now, as I mentioned at the start of the tutorial, guys, I have included a bonus tutorial in this video, which doesn't actually involve responsive images, but this is a problem that people run into all the time regarding images, and many don't really know how to fix the issue, so we're going to address the issue now. So we're inside VS Code, guys, and inside this file you can see we have a div with a class of container, which has our image of the elephant in there. And inside the style sheet you can see the container has a width of 80% and margin auto on either side, just so it's centered, and we also have a border around this. And you can also see that the image has a width of 100%, so it fits 100% of the container at all times. Now there are instances where we might run into this issue, and it sometimes can be tricky to notice, but if we look at the bottom of the image here, you can see there's a little gap between the image and the border of the container, and this can actually be a bit of an inconvenience, especially if you change background colors for certain sections. This may become more prominent, and many people don't really know why it's there. Now the reason this happens is because images are in fact inline elements They behave like inline block, but they are in fact inline elements. And by default, inline elements have a little space at the bottom underneath them. So this is actually a really simple fix, and all we've got to really do is just go inside the image tag here and just set the display to block. And as you can see now, it fills up the whole of the container and there's no longer that little gap that you see there. And it's really as simple as that. So this section wasn't really about responsive images, but I just wanted to throw this in there as we're on the topic of images, and many people run into this issue and never really know how to fix it. So that's going to conclude the video, guys. If you enjoyed the content, be sure to hit that like button and consider subscribing to the channel, and I'll see you guys next time.